continuing to work on the Intro to Logs assignment. We're starting with number 9. Okay, so this is where they start to get a little bit more, there's a little more process going on here, but we're still not going to use a calculator because we're still just going to leave our solutions in log form. Okay, so log, a way of rewriting an exponent so that it's no longer in the exponent. That's what we do when we have variables up here, 5k. So on number 9, there's an 8 there. We have to get everything except that exponent. We need to move it to the other side if we can. Okay, so if 11 to the 5k is being multiplied by 8, we're going to divide by 8. So we got 11 to the 5k is equal to 0.5. Right. And so how am I going to get rid of that 5k? I'm going to do a log of both sides. And the way I'm going to write it is by saying log base 11 on both sides, log base 11. So golden rule of algebra, do to one side what you do to the other. So I'm taking the whole log base 11 of 11 to the 5k. And what happens is now the 5k comes out front. And then up with 5k times the log base 11 of 11 is equal to log base 11 of 0.5. Okay, and that seems complicated. We're going to simplify it a little bit on number 11. But so log base 11 of 11, that is just the definition of a log. 11 to what power is 11? Just 1. So that the answer to a log is just an exponent, and that exponent is 1, which only leaves us with 5k is equal to log base 11 of 0.5. So hopefully you can see a way to get from here over to here, maybe skipping that step in between. So you see the 11 on the left side goes away because now we've got a log base 11 on the right. All right, then we're going to divide that by 5. And this is it. This is the solution because we're leaving it in log form. We're not going to get rid of anything. And we'll talk about some properties that might allow us to rewrite that if we had a notion to. Okay, so this is a log that's being multiplied by 1/5, so we could raise that to the 1/5 if we wanted to. Another way to write it. All right, but if you can get what's in the box, I'm happy. All right, number 10, we see this mysterious e come into play that we dealt with compound interest. Okay, we're going to get that thing by itself. E to the m plus 10 is equal to 47. All right, and a log with a base of e has its own special designation. It's called the natural log. So what we're going to do is take the natural log of both sides because it has a base of e. Natural log of 47. And this is just 1. The m plus 10 comes down. M plus 10 is equal to the natural log of 47. And you don't have to write the base of e on a natural log because in the math world, that's what it is. That's its definition. Natural log has a base of e. Just like if you type a log into your calculator, it has a base of 10, unless it says something else. Natural log has a base of e. And then we're going to subtract 10 from both sides, and we get that m is just the natural log of 47. So e to what power equals 47? That'll give us a number, and we'll subtract 10 from that number, and that's what m is. Let's do a little more soothing colors for number 11. We're going to add 5 to both sides. Get that 15 to the 10x is equal to 63. Okay, and so now for number 11, you can keep doing it the same way, but on number 11, I'm going to think about this as I am changing its form. Okay, so 15 to the what power equals 63. If I were to write that as a log, I would have 15 as the base. So what power do I raise 15 to? I don't know. That's the other side of the equal sign. But I do know that when I raise 15 to that power, I get 63. Okay, so what was in the exponent? Just a 10x. So we've got log base 15 of 63 equals 10x. And then we're going to divide by 10 on both sides. We get that x is equal to log base 15 of 63 divided by 10. We'll call that good. That's our answer there.